To solve for the variables x, y, and z for this given circle P, we need to look into the consideration of the relationships or the representations of the given variables. For x, it represents this central angle, as this is the angle formed by the two radii of the circle and where the vertex is at the center of circle P. Y is what we call as the intercepted arc of angle x. And z is this angle, is this arc on this side, which is a minor arc formed by the endpoints of these two diameters here. So let's start with solving the value of x. There's only one given here, which is 150 degrees, being this intercepted arc. And since x is what we know as a central angle, we know that the measurement of a central angle is equal or just the same as the measurement of its intercepted arc. However, for the central angle x, its intercepted arc is arc y, to which we don't know yet the value as well. What we need to understand here is that there is a unique relationship between this angle x and the angle directly opposite it facing the intercepted arc that measures 150 degrees. If you can still remember, these two angles are what we call as vertical angles. They are actually angles on the opposite ends that are formed when two lines intersect. And according to the vertical angles theorem, vertical angles are considered to be congruent or has the same measurement. In short, if this is x here, and no matter what the value of x here, this is also measured as x. Because then again, they are considered to be vertical angles, and vertical angles are congruent. The reason why we do this is that when we assume that this angle here is just the same as its vertical angle represented by variable x, we cannot draw a relationship between this similar or angle that has the same measurement with x and its intercepted arc, which measures 150 degrees. Because then again, this is a central angle, and the measurement of that central angle x is just equal to the measurement of its intercepted arc. In short, the measurement of angle x is equal to 150 degrees. This is also now true with the original given variable x here, as these two are again congruent or has the same measurement because they are considered to be vertical angles. For arc y, since we already know that this measures 150 degrees and this is also the same as that because they are vertical angles, this means that this central angle is equal to the measurement of this intercepted arc. And since x is given to be 150 degrees, this intercepted arc of that given angle x, which is represented by y, is also 150 degrees. The reason being is that we already have the values for x, and the relationship for the central angle and the arc, or its intercepted arc, is that they have the same measurement. Now, in solving for arc z here, we cannot use the value of this central angle because we don't know its value yet. And even if we use the same concept earlier in solving x and y, the other side, or the other central angle, and its intercepted arc also doesn't have any measurement. But we could solve the value of this angle, central angle, which will relate later on to the variable z, by looking into the perspective of this angle x and this central angle intercepting arc Z. They are actually angles, adjacent angles specifically, that are forming a linear pair. A linear pair is a pair of adjacent angles that when added could sum up into 180 degrees. In short, this measurement, which is 150 degrees, to be added by this unknown measurement must be 180 degrees. And since this is an intercepted arc, and this is its central angle, and they are the same, I could just also label this as Z. And I could make this symbolic notation that the measurement of angle X plus the measurement of angle Z must be equal to 180 degrees. Simply plug in the value for the measurement of angle X, 150 degrees, plus the measurement of angle Z. Don't worry about whether Z is an angle or arc. Again, they are just having the same measurement, equal to 180 degrees. And by doing that, we could show that the measurement of angle Z is 180 degrees less 150, which would be equal to 30 degrees. Again, this is still the central angle, which is represented by the same variable because they have the same measurement. And in that case, the value of arc, that is the minor arc that is represented by Z, since it's the intercepted arc of the central angle Z here, which measures 30 degrees, this is also 30 degrees. There is also another way to look into what would be the value of arc Z. Look into this perspective, this portion of an arc. This is an example of a semicircle. A semicircle is half the circumference of a circle, and hence its measurement is also half the measurement of the entire circumference, which is 360 degrees. And since y is already given as 150 degrees, the value of z is something that when added to 150 degrees will get the result of 180 as a semicircle. Still 30 degrees. This is how we solve the variables x, y, and z for this given circle P.